Hello everyone, welcome back. In this video, we're going to talk about the for loop. We've used the while loop in order to construct loops in C++, but there are two more loop constructs we have to talk about, including the for loop and the do while loop. So in this video, let's begin our discussion of for loops. Go ahead and open up a new file in gedit called forloopfun.cpp and code up an empty main function. We're going to talk about the for loop on the whiteboard, its general template, and some notes about it, and then we're just going to solve some problems in forloopfun.cpp. Let's take a look at the general template of a for loop. For loops start with the for reserved word instead of while loops, and then they have parentheses. But what goes in the parentheses is a little bit different than while loops and if statements. We will specify a Boolean condition, but we'll also specify two other pieces of information. First, there's a location in the for loop designated for initialization code. So this might be initializing your loop control variables, for example. With a while loop, we would usually put our initialization code before the while loop. But the for loop has a designated spot for the initialization code. And then there's a semicolon. If you don't have the initialization code or you don't want to put it here, you can leave this spot blank, but you do have to have this semicolon here. After the first semicolon is the location for our Boolean condition. So this is the same Boolean condition that we've been working with in a while loop. This is tested each iteration of the loop in order to determine, are we going to keep looping or not? If the Boolean condition evaluates to true, we continue looping. If it evaluates to false, we exit the loop. After the Boolean condition, we have a semicolon and a designated spot for our progress towards our Boolean condition being false. And then our curly braces. So for loops are kind of nice because there are designated spots for all of the loop control variable related code that a while loop has, right? You need to initialize the loop control variables. You need to test the loop control variables to see if they need some sort of condition where you need to stop executing your loop. And you need to have that progress towards your Boolean condition being false, which would be updating your loop control variables. All right, inside of the for loop, we have our for loop body. Which could be one or more executable statements. Note that in a while loop, we would have our progress towards our Boolean condition being false somewhere in this body. But thankfully, with our for loop, we have a designated spot for our progress towards our Boolean condition being false. Okay, so let's go ahead and work an example of for loops. The example we're going to work is the exact same one that we worked for our while loop, which is printing n stars, or numstars, number of stars. I'm going to go ahead and erase this so that we can work over here in the left corner. before we do this, I think it would be good if we take a look at the flow chart for a for loop. So we looked at the flow chart for a while loop, and now we'll see one for a for loop. So our for loop starts by executing the initialization code, and it is used for initialization. And then the condition is tested. If the condition is true, then the body of the loop is executed. So that would be this code here. And then the increment code is executed, which is the last spot in our 3 spots of our for loop here. And then after the increment occurs, or what I call the progress towards the Boolean condition being false, we head up to condition and test again. This looping sequence continues until this condition evaluates to false. Then execution resumes at the first executable line of code after the for loop. All right. So recall with our numstars example, we have a variable called numstars, which is initialized to some value greater than 0, like 5. We could even initialize it to 0 and then prompt the user to enter in a value for numstars. Regardless, we're just looking for some kind of integer greater than 0 that tells us the number of stars to print on one line. For example, when numstars is 5, we're looking for 5 stars all on one line, followed by a new line character. Okay. Next we'll have our loop control variable, I. I could initialize I. I think it's good practice to initialize your variables when you declare them, but I'm purposely not going to initialize I because we'll have a designated spot in our for loop to do that. All right, now we're down to our for loop. First spot in our for loop is for our initialization code that I was just alluding to. And we're going to run I from 0, stopping at 5. So I'll initialize I to 0. I could do a few other things here, like maybe I have another loop control variable, j, and I could just put I is assigned 0, comma, j is assigned 0, or whatever I'd like. Or I can omit this if I don't want this here at all. Maybe I want to initialize I to 0 up here. I could omit this and just leave it blank. Okay, next we have our Boolean condition, which is I less than numstars. This is the same Boolean condition we had on our while loop. And then lastly, we have our progress towards our Boolean condition being false, or you'll also see this often called the update. Just add 1 to I. Now, in the body of our for loop, we only have one statement, our cout statement. In our while loop, we also had our progress towards our Boolean condition being false in the body, but here in our for loop, we have a designated spot for it. Awesome. We have our solution coded up. Before we trace through it, I want to comment 2 more things. I've mentioned that we can omit the initialization code here and just leave it blank. Well, you can do that for the Boolean condition and for the progress. In fact, you could have a for loop that looks like this. Just 2 semicolons. It's probably clear that we could put the progress towards the Boolean condition being false in the body because we did that with our while loop. We could put our initialization code before the for loop because we did that with our while loop. But how could we omit a Boolean condition here? Well, this is kind of tricky, and it actually involves the idea of something called a break statement, which we'll cover in a later video. But if you ever see something in the wild, perhaps online, where there's missing code in each of these 3 spots, it's okay, it's not required, but this is typically the form and the norm. Okay, so let's go ahead and label our code just like we did with our while loop. Initialization code will be location number 1. Specific initialization code inside of the for loop will be 1A. Our Boolean condition will be 2. Our cout statement will be 2A. Our progress towards our Boolean condition being false will be 2B. And then our first executable statement outside of the loop will be 3. We'll need to add some arrows to show how our code executes. After we declare and initialize our variables, we'll come in to the initialization portion of our for loop. After we initialize our code, we test to make sure that our Boolean condition is met so that we can repeat. If this is true, we enter the body of the for loop. If this is false, then we exit the loop and we're down here at line number or location number 3. After 2A, we're up here doing our progress towards our Boolean condition being false. After we make our update, then we're back to 2, where we test our Boolean condition and see if we're going to continue looping or if we're going to finish looping and exit the for loop structure. All right, so let's go ahead and make our table so we can trace through our loop control variable and our output. Okay, here we go. So we're at location number 1. numstars is initialized to 5. The variable I is declared, but it's not initialized. So I'm going to put a question mark there. It's a garbage value. We don't know what it is. From 1, we head to 1A, where we initialize I to 0. So we overwrite whatever garbage value was in I with 0. From our initialization code at 1A, we head to our Boolean condition at 2, and we test, is I less than numstars? Is 0 less than 5? Yes, it is. We come in to the body of our for loop at 2A, and we print out a star. From 2A, we head up to our progress towards our Boolean condition being false, and we update our loop control variable by adding 1. From here, we head over to our Boolean condition and we test. Is I less than numstars? Is 1 less than 5? It is. We enter the body and we print out a star. From the body, we head up to progress. 1 becomes 2. We come over to the Boolean condition. Is I less than numstars? Is 2 less than 5? It is. We enter the body. We print out a star. We come up to our progress towards our Boolean condition being false. 1 is added to 2, so I becomes 3. We head over to our BC. We test, is I less than numstars? Is 3 less than 5? It is. We enter the body and we print out a star. From the body, we head up to our progress towards our Boolean condition being false. Add 1 to I is now 4. We head over to our BC. Is I less than numstars? Is 4 less than 5? It is. So we enter the body of our for loop and we print out a star. Then we head up to our progress, add 1 to I. I is now 5. We head over to our BC. We test, is I less than numstars? Is 5 less than 5? It is not. So we exit our loop following the false path, which takes us down here to 3, and we print out a new line character, which gives us the output that we would expect. All right, so I'll go ahead and just write your task up here on the board, which is code this up. Go ahead and head over to our forloopfun.cpp file and code up this for loop. Wonderful. So it looks like we got the same output as our while loop solution. So we've seen that within a while loop, there are multiple ways to solve the same problem. Now we know how to solve a problem using completely different constructs in C++. The next thing that we want to do is continue solving some for loop examples so that you get more comfortable working with for loops. So let's take a stab at our next example, which is rewriting our first 20 even number code to use a for loop instead of a while loop. So that's a task for you to pause the video and try right now. When we solved our first 20 even numbers problem with while loops, we solved it 3 different ways. We can also solve our first 20 even numbers problem with a for loop, and we can solve it multiple ways using a for loop. So if you've got one solution for your for loop, go ahead and head back over to the code we wrote for first 20 even numbers with while loops and see if you can convert those other 2 approaches into for loops. It would be great practice. All right, let's start with the first one we did when we were coding up our solution using a while loop. Walking I from 2 to 40, going up 2 at a time. Beautiful. And then our next approach was still to go from 2 to 40, but go up 1 at a time and then test to see if I is an even number before we print it out. And then our last solution that we solved for our first 20 even numbers using a while loop had us going from 1 to 20, 1 at a time, but multiplying I by 2 before we displayed it. Wonderful. All right. Another problem that we could solve using for loops is our transaction fund code. Rather than coding that up, I'm just going to go ahead and show you it reworked using a for loop instead of a while loop. So before we had while I is less than num transactions and then I++, we can just replace that with a for loop, putting our Boolean condition in our middle spot, our progress towards our Boolean condition being false in our last spot, and then variable initialization in the first spot. To wrap up our conversation on for loops, let's talk about when we should use for loops and when we should use while loops. Well, first off, while loops are our most versatile looping construct. If your problem can be solved using a loop, it can be solved using a while loop. For loops, however, cannot be used to solve all problems. For example, could we rewrite our guessing game code to use a for loop? We actually could not, because we don't know in advance how many times the loop is going to execute. We don't know how many wrong guesses the user is going to make until they make a correct guess. So we'll want to use a while loop in those kinds of instances when we don't know in advance the number of times we want the loop to run. So that means for loops are really good for loops that count things. Going, say, from 1 to 100 or 1 to 5. Those are really great applications for loops. With the designated spots for initialization, BC, and progress, it makes it much easier to debug and write good, clean code. With while loops, we'll use them for everything else. Prompting for user input, menus. We can also use them for counter loops, etc.